Hello, friend. Welcome to Science for Sleep. Tonight, we are beginning with something many people have seen before, but may not have fully considered. A tree stump, a cut branch, a round slice of wood with lines spreading outward from a still center. At first, it can look simple, almost decorative, as if the tree has been marked with careful circles for no reason at all. But those circles are not decoration. They are growth made visible. They are time held in place. Most people already know the first quiet fact about tree rings. In many trees, each ring usually represents 1 year of growth. That alone is enough to make a trunk feel a little different. It means the wood is not just wood. It is a layered record of passing seasons. 1 year laid down beside another, then another, then another, until the whole body of the tree becomes a kind of calendar made of living tissue, turned slowly into structure. And yet, rings are more than a way of counting age. A tree does not add each year in exactly the same way. Some years leave wider bands. Some leave thinner ones. A narrow ring can be the quiet sign of a difficult year, when water was scarce, temperatures were unfavorable, or growth was interrupted by stress. A wider ring may suggest a season with more favorable conditions, when the tree had enough moisture, enough warmth, and enough time to build more wood than it could in a harder year. So even before we go any deeper, the trunk is already telling two stories at once. One is the simple story of how long the tree lived. The other is the gentler and more detailed story of what those years were like. There is something else quietly surprising inside that round piece of wood. The oldest part of the tree is not the bark on the outside. It is the hidden center. The wood nearest the middle was formed when the tree was youngest, when it may have been little more than a thin stem lifting itself into the air. Everything surrounding that center came later. Each new year formed not at the center, but just beneath the bark, adding another layer around what was already there. So when you look inward, you are also looking backward. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. Once that idea settles in, tree rings begin to feel almost impossible to ignore. A trunk is not only a shape that stood in a forest or along a road. It is a slow record of conditions that came and went, while the tree remained rooted in one place. Dry summers, favorable springs, years of calm, years of strain. In some trees, rings may even preserve signs of fire, injury, or insect damage, because the wood formed during those periods can change in visible ways. What looks at first like a set of simple circles can turn out to be a long physical memory. And one tree does not have to keep its record alone. Scientists can compare the pattern of wide and narrow rings from different trees growing in the same region. If several trees show the same sequence, narrow, wide, narrow, narrow, wide, that shared pattern can be matched across trunks like an overlapping timeline. This is one of the reasons tree rings are so useful. They do not only describe one life, they can also help reveal the history of a place. So tonight, as we begin, it helps to picture that quiet cross-section of wood once more. The still center, the circles widening outward, the faint contrast between one year and the next. What seems at first like a simple surface is really the visible result of seasons repeating, growth changing, and time settling gently into form. A tree does not try to remember. It simply grows. And in growing, it keeps far more than it seems. A tree does not grow in exactly the same way all year. Even though it may look still from the outside, with its trunk fixed in place and its branches held in a familiar shape, its growth is tied closely to changing conditions around it. Light changes, temperature changes, water availability changes. The length of the day shifts slowly across the year. And because of that, the work of building new wood rises and falls in a quiet seasonal rhythm. This is one of the main reasons tree rings exist at all. In places where the year is divided clearly into spring, summer, autumn, and winter, trees often experience a distinct growing season followed by a period of slowdown or near dormancy. When conditions become favorable again, growth resumes. That pattern, repeated over and over, helps create the visible layers we later call rings. So before a tree ring is ever a ring to our eyes, it is first a change in pace, a season of more active growth, followed by slower growth, followed by a pause, and then a beginning again. Spring is often the easiest place to imagine this process. After winter, temperatures begin to rise, the ground thaws, water becomes easier to take up through the roots. Longer days provide more light for photosynthesis. Buds open. Leaves return or expand. The tree begins moving into a more active state, and new growth begins to form. This part of the year can feel full of momentum. The tree is not rushing in any human sense, but compared with winter, its internal activity has clearly shifted. As the growing season continues, the conditions around the tree begin to change again. In some places, summer may remain favorable for a long time. In others, it may gradually become hotter and drier. Soil moisture can decline. Day length starts to shorten after reaching its peak. The tree is still growing, but not always in the same way it was earlier. Its pace can slow. The kind of cells it produces can change. The year begins to leave behind contrast. Then, eventually, growth slows much more sharply. In colder climates, this happens as autumn moves toward winter. Temperatures drop. Leaves may fall from deciduous trees. Water becomes harder to move when the ground freezes or when the tree enters a resting state. In dry climates, the slow period may be tied less to cold and more to lack of moisture. But either way, the tree is no longer building wood with the same steady rhythm it had during the active part of the year. This is important because rings do not appear simply because time passes. They appear because growth changes. If a tree grew in exactly the same way every day, under exactly the same conditions, the wood would be much more uniform. There would be far less contrast from one part of the year to the next. The trunk might still become thicker over time, but the visible pattern would be weaker. What gives many trees their ringed appearance is not just growth itself, but the rise and fall of growth across a repeating cycle. That repeating cycle can be very gentle. A tree does not wake up one morning in spring and suddenly draw a dark line around itself. The process is gradual. It unfolds cell by cell. But over many months, the difference between earlier growth and later growth becomes clear enough to remain visible in the wood. 1 year is not a single stroke. It is a slow transition from beginning to fullness, to slow down, to pause. There is something quietly beautiful about that. The trunk becomes a record, not because the tree is trying to preserve history, but because it cannot help responding to the world around it. Warmth encourages one kind of growth. Dryness limits another. Winter or drought slows the process almost to stillness. The tree does not announce these changes. It absorbs them and then continues. When we think of a tree, it is easy to imagine something constant. The same trunk, the same bark, the same branches reaching into familiar air. But inside that steady shape, the year is never perfectly uniform. A tree lives through cycles of abundance and restraint. Times when growth comes more easily, and times when it slows almost to silence. And each time that rhythm repeats, the trunk holds onto the evidence. So before we even talk about the exact look of a ring, it helps to understand this first principle. A ring begins as a season. More precisely, it begins as a difference between seasons. It is the visible result of a tree growing under changing conditions rather than stable ones. Spring does not look like winter inside the trunk. Early growth does not look exactly like later growth. And because those differences return year after year, the wood slowly becomes readable. What appears, at first glance, to be a single tree ring is not really a single uniform band. It is more like a yearly pairing, a contrast between growth made under one set of conditions and growth made under another. The ring we notice with our eyes exists because the tree does not build identical wood. From the beginning of the growing season to the end of it. This difference is usually described with two names, early wood and late wood. Early wood is the part formed earlier in the growing season, often during spring or the more favorable opening stretch of growth. It is usually lighter in color and can appear wider and softer in texture. The cells produced during this time are often larger, with relatively thinner walls. That structure helps the tree move water upward when activity is high and fresh growth is underway. If the tree is leafing out, expanding, and taking advantage of available moisture and light, it needs an efficient way to support that work. Early wood helps provide it. Late wood forms later, after that first surge has eased. It is often darker, denser, and narrower than the lighter band beside it. The cells produced during this period tend to be smaller, with thicker walls. Rather than emphasizing rapid movement of water in the same way, this growth contributes more to density and strength. So although early wood and late wood are both made by the same tree, during the same year, they do not look or behave quite the same. That contrast is what gives many tree rings their visible structure. If you were to study a polished cross-section of a trunk, you might notice that part of each ring looks pale and broad, while another part appears darker and more tightly compressed. The pale area is commonly the early wood. The darker edge is usually the late wood. Together, they form the annual pattern that people casually call a ring. So a ring is not merely a line. It is a full cycle of changing growth, with one phase gradually giving way to another. This makes the trunk feel more alive, even after it has been cut. The wood is not just stacked in repetitive layers. it carries the rhythm of changing internal priorities. During the earlier part of the season, the tree is often focused on active transport, expansion, and making use of favorable conditions. Later, as those conditions begin to shift, the wood changes character. The cells become more compact. The structure becomes firmer. The year settles into a different form. There is also something quietly elegant about the fact that this contrast is not decorative at all. It is functional. The lighter and darker zones are not there to help us read the tree. They exist because the tree had different needs at different times of the year. Only afterward do those practical differences become a visible record for human eyes. In many species, this change from early wood to late wood is clear enough that the trunk becomes easy to read. In others, the contrast is subtler. The exact appearance depends on the species, the environment, and how strongly the seasons shape the tree's growth. But the underlying idea remains the same. A ring becomes visible because wood formed during one part of the year differs from wood formed during another part. That is why tree rings are more than just marks of passing time. They are signs of changing biological activity. Even within a single year, the trunk is not repeating itself perfectly. It is adjusting. It is responding to moisture, temperature, light, and timing. The wood records not only that a year happened, but that the year unfolded. When people picture tree rings, they often imagine dark circular lines drawn neatly across wood, almost like the grooves of a fingerprint. But the real picture is softer and more gradual than that. Early wood fades into late wood. One growing season settles to a close. Then, after a pause, another begins. The boundary we notice is simply where one yearly rhythm ended and another one eventually took shape around it. So the ring is not a line that was added to the tree. It is the visible meeting point between two growth styles that belong to the same living cycle. A tree builds lighter, larger-celled wood when conditions invite speed and movement. It builds denser, smaller-celled wood when the season matures and growth becomes more restrained. Pressed together year after year, those changes create one of the clearest natural patterns most of us will ever see without realizing how much is hidden inside it. One of the most familiar ideas about tree rings is that one ring usually equals 1 year. It is a simple idea, and in many cases, it is true enough to be very useful. But what makes that possible is not time alone. A tree does not place a neat mark inside itself just because another 12 months have passed. The yearly ring appears because the tree is living through a repeating cycle of growth, slowdown, and renewed growth again. In climates with clear seasons, that cycle often becomes regular enough to leave behind one visible annual pattern. Spring brings a more active period. Summer continues it, though not always in the same way. Autumn and winter bring decline, rest, or dormancy. Then the pattern begins again. Because the tree's wood changes as the year changes, each full growing cycle can leave one recognizable ring. This is why the phrase "one ring per year" works best in places where the seasons are strong and dependable. A tree, growing where winter is cold and spring returns, clearly has a much easier time producing distinct annual boundaries. The same is often true in places with a pronounced wet season and dry season. What matters is not the names of the seasons themselves, but the fact that the year has a rhythm sharp enough to interrupt growth and then begin it again. That interruption matters. Without it, the wood would not separate so clearly into yearly units. A tree in a strongly seasonal climate is almost like a living organism that breathes in long, slow waves. During favorable periods, it produces new cells actively. During less favorable periods, that activity slows or nearly stops. When growth starts up again, the new wood forms outside the layer from the previous year, and the contrast becomes readable. After enough repetition, the trunk becomes a stack of annual growth histories, arranged from oldest in the center to newest near the bark. There is something comforting about that order. The trunk becomes a physical record of patience. A tree does not leap from one age to another. It adds itself gradually, one season at a time, holding each earlier year inside the next. The result is so orderly that a person can look at a cut trunk and often count backward through decades with nothing more than their eyes. Still, the yearly pattern is not always as perfect as it first sounds. Sometimes a tree can produce a false ring, which happens when unusual conditions during a single growing season create a change in wood that looks like a year boundary, even though no full year has passed. A sudden dry spell followed by renewed growth can sometimes create that effect. In other cases, a tree may barely grow in a difficult year, leaving a ring that is extremely thin and easy to miss. So while one ring per year is often a very good rule, it is not a magical rule. It works because biology and climate often cooperate in a predictable way, not because trees are obliged to mark time cleanly. That is part of what makes tree rings interesting rather than mechanical. They are reliable enough to be powerful, but natural enough to remain subtle. A tree is not a clock built by human hands. It is a living thing responding to weather, light, water, temperature, soil, competition, and stress. The yearly ring emerges from that lived rhythm. When people casually say a tree has 50 rings and is therefore 50 years old, they are usually speaking in a simplified but meaningful way. In many cases, that count gives a solid estimate of how many growing seasons the trunk experienced at that point. It turns visible wood into a readable measure of time, and that alone is remarkable. Few ordinary objects around us hold years so openly. The deeper truth is that one ring usually becomes 1 year because the year itself is not uniform. It has shape. It has contrast. It contains beginnings, active stretches, slowing phases, and still periods. Trees respond to that shape by building different kinds of wood at different times. And when the cycle returns again and again, the trunk quietly becomes a calendar. So the yearly ring is not simply a sign of age. It is the visible result of repetition in nature. A return of growth, a pause, and another return. That is what makes the pattern so readable, and also what makes it feel so steady to look at. The tree has spent its whole life turning changing seasons into structure, one year folded carefully around the last. The rings of a tree may look as though they were formed deep inside the trunk, as if the center were the place where growth begins and then spreads outward. But the real source of new wood is not the center at all. It is a very thin living layer close to the outside of the tree, hidden just beneath the bark. This layer is called the cambium, and though it is easy to overlook, it is one of the most important parts of the trunk. The cambium is where new growth is made. It forms a narrow sheath of actively dividing cells that wraps around the stem, branches, and roots of woody plants. Year after year, this delicate layer produces new tissue. Some of that tissue is added inward and becomes wood. Some is added outward and becomes part of the inner bark. This means the tree is not thickening by expanding from the middle like bread rising in an oven. It is thickening because new layers are being built near the outside, while older layers remain in place beneath them. That simple idea changes the way a trunk is understood. The center of the tree is not the place where growth is happening now. It is the place where growth happened long ago. The wood there may have been formed when the tree was still young, perhaps when it was only a sapling standing in a much smaller patch of light. Everything closer to the bark came later. Each year, the cambium laid down another thin addition outside the last one, gently widening the trunk over time. This is why the youngest ring is always nearest the bark, and the oldest growth lies nearest the center. When people look at a cross-section and count inward, they are moving backward through the life of the tree. The outer edge is the most recent chapter. The inner wood belongs to earlier years. A trunk is arranged almost like memory layered in reverse, with the past held inside and the present forming quietly at the edge. The cambium itself is so thin that it would not stand out much if seen on its own. Yet from that thinness comes the entire thickness of the trunk. A massive tree, wide enough that a person might struggle to wrap both arms around it, owes its size to the repeated work of this narrow living band. The older wood inside no longer divides or expands. It remains as structure, support, and record. The cambium is the place where new cells are made and where the tree continues adding to itself. There is something almost surprising about how little of a large trunk is truly alive in the most active sense. The bark on the outside protects. The cambium builds. Just inside that, younger wood helps move water upward through the tree. Deeper within, much of the older wood remains as support and stored history. A tree can appear solid and uniform from a distance, but within it, different layers are doing very different kinds of work. This outward pattern of growth also explains why the bark cracks, stretches, and changes over time. As the cambium adds new layers of wood beneath it, the outer covering must adjust to a trunk that is slowly widening. In some trees, the bark flakes away. In others, it furrows or peels. The changes on the outside are part of the same quiet process that is building rings on the inside. Once the cambium is understood, the trunk becomes easier to picture as a living process rather than a fixed object. New growth is not appearing at the center and pushing everything outward. It is being added in a narrow ring beneath the bark, one season at a time. The tree keeps its earlier years enclosed within itself, while the newest layer arrives gently around them. That is how a trunk grows thicker without replacing what came before. The result is a structure that is both living and historical at once. The cambium continues its careful work near the edge, while the wood it formed in earlier years remains inside as support, transport tissue, and visible record. A tree therefore carries its whole life with it. Not all of that life is equally active, but much of it is still present. The trunk is not merely a column holding up branches. It is a layered body, built by a thin, persistent line of living cells just beneath the bark. quietly adding another year to the outside while keeping every earlier year held within. Fresh growth begins as living tissue, but it does not stay in that first soft state for long. What a tree adds each year starts as a narrow band of newly formed cells near the outside of the trunk, close to the cambium. These cells are delicate at first. They are alive, active, and still becoming what they are meant to be. Over time, though, many of them will lose that early softness and become part of the firm wood that gives the tree its shape, strength, and visible rings. The cambium, as we have already seen, is the thin living layer that creates new growth. It produces tissue in two directions. Toward the inside, it makes xylem. Toward the outside, it makes phloem. Phloem helps carry sugars and other products of photosynthesis through the tree, especially from the leaves to other tissues that need energy. Xylem is the tissue that becomes wood. It helps move water upward from the roots, and over time, it also becomes one of the main structural materials of the trunk itself. Because tree rings are made of wood, xylem is the more important part of the story here. When a new layer of xylem is first produced, it is not yet the dense and settled material people usually imagine when they think of wood. It begins as living tissue made of fresh cells that are still enlarging, changing, and taking on specialized roles. Some of these cells help conduct water and dissolved minerals upward through the tree. During the active growing season, that job is essential. Leaves need water. Expanding tissues need water. Cooling and transport depend on it. The new xylem helps support that flow. As these cells mature, their character changes. Their walls thicken. Their shapes settle. Many of them lose their living contents and become hollow conduits or supporting elements. Depending on the type of cell and the species of tree. This might sound strange at first, but much of the wood inside a tree is made of cells that are no longer alive in the usual sense. They remain as structure. They remain as pathways. They remain as part of the body of the tree, even after their active life as living cells has ended. That is one of the quiet transformations taking place inside every trunk. New growth begins as living tissue, but much of it gradually becomes a durable framework. The tree is not only building a transport system for the present, it is also building support that will remain in place for years, decades, and sometimes centuries. This helps explain why the trunk is made mostly of older xylem from past growing seasons. Each year, the cambium adds a new layer inward. That newest xylem begins its useful life near the outside of the wood. Then, as more years pass and newer layers form beyond it, the older xylem is pushed farther toward the center, not by movement, but by the simple addition of more layers around it. The older wood remains where it was formed, held inside the growing trunk like an earlier chapter enclosed by later ones. In many trees, only the outer portion of the xylem remains fully active in carrying water. Deeper inside, older xylem may still contribute to support, even if it no longer plays as large a role in water transport. This is part of why the trunk can be both functional and historical at once. The outer wood is closer to present activity. The inner wood is older, quieter, and often more devoted to structure than transport. When a person looks at a cross-section of a tree, they are seeing the result of this repeated transformation. Each ring began as a new layer of xylem made by the cambium. At first, it was fresh growth, soft compared with what it would become. Later, it matured, strengthened, and remained behind as part of the trunk. Then, another year, added another layer outside it, and another. The trunk is therefore not one solid object made all at once. It is a long accumulation of once living layers, each one formed in its own season and then preserved within the whole. That is part of what makes wood feel so different once its formation is understood. It is not inert material in the ordinary sense. It is former growth, former movement, former water pathways. What now seems still and solid was once newly made, full of change and closely tied to the needs of a particular season. Over time, those temporary living tissues became lasting structure. Each ring, then, is more than a mark. It is the remains of a year's construction. It began at the edge of the tree as new xylem, helping support the life of the present season. Later, it matured into wood and took its place among the layers of earlier years. That process repeats so quietly that from the outside, the tree appears almost motionless. Yet inside it, season after season, soft new growth is steadily becoming history. The interesting question is why those yearly layers can look so different from one another, even though they are made by the same tree in the same trunk over the course of one life. The trunk is not a perfect clock. It does not produce the same amount of growth every year with calm mechanical precision. Instead, it responds to whatever each year offers. A tree may stand in the same place for decades, even centuries, but the conditions around it are never exactly repeated. Some years bring more water, some bring less, some are warm and long, some are cool and short. And because of that, the rings in a tree can vary greatly in width from one year to the next. This is one of the reasons tree rings are so informative. If every ring were the same thickness, they would still mark time, but they would say far less about the life of the tree. The fact that one ring can be broad and another narrow means the trunk is preserving more than age alone. It is preserving variation. It is keeping a physical trace of how favorable or difficult different years were for growth. A wide ring usually means that the tree added more wood during that growing season. A narrow ring usually means it added less. That sounds simple, but behind it is a whole collection of influences working together. Water is one of the most important. A tree with enough moisture can generally maintain photosynthesis more effectively, move nutrients more steadily, and keep producing the new cells that later become wood. When water is scarce, that process becomes harder. Growth may slow, and the ring formed that year may end up thinner. Temperature matters too. In climates where warmth is limited, a cool year can shorten the growing period or slow the internal processes that support wood formation. In more moderate regions, temperature may still influence how early growth begins in spring and how long it can continue before conditions shift again. Sunlight also plays a role, since photosynthesis depends on it. The tree needs light to produce the sugars that help power growth. Soil quality, competition from nearby trees, insect stress, disease, and damage can also shape how much wood is added in a given year. All of this means that ring width is not caused by one single factor in every case. It is the result of the tree's overall experience during that season. A healthy tree growing in a favorable year often has a better chance of producing a wider ring. If water is available, temperatures are suitable, and the growing season is long enough, the cambium can remain active for longer and produce more xylem. More cells are formed. More wood is laid down. The trunk widens a little more than it did during a more difficult year. Over time, these differences accumulate into a visible pattern of wider and narrower bands that reflect changing conditions across the tree's life. Stress can interrupt that pattern very quickly. A tree under strain may reduce cell production because it has fewer resources to devote to growth. If drought limits water, if cold shortens the season, if insects damage the leaves, or if roots struggle in poor soil, the cambium may produce less wood. The resulting ring can be narrow, faint, and easy to distinguish from the thicker growth of a better year. A narrow ring is not just a small ring. It is often a sign that the tree had to live more carefully during that period. That is part of what makes the trunk feel so responsive once you know how to look at it. It is not recording years in a detached way. It is recording the terms on which those years were lived. It is also important to remember that ring width does not simply shrink because a tree is getting older. People sometimes assume that thin rings always mean old age, and there is some reason for that impression, since growth patterns can change as trees mature. But a narrow ring is not automatically just a sign of age. It can reflect environmental limits, temporary stress, or a particularly hard season. A wider ring does not simply mean youth, and a thinner ring does not simply mean age. The tree's surroundings matter too much for the story to be that simple. When many years are placed side by side inside the same trunk, a pattern begins to emerge. Some periods look generous, with repeated wider growth. Others look restrained, with several narrow years close together. The tree may have stood in one place the whole time, yet the wood shows that the world around it was never still. Conditions shifted, resources changed. The trunk answered by growing more in some years and less in others. That is why a tree ring should not be thought of as a fixed measure, like a ruler mark. It is better understood as a response. Each ring reflects what the tree was able to do under the conditions of that year. The trunk keeps those responses in order, one outside another, until the whole tree becomes a layered record of favorable seasons, difficult seasons, and everything in between. Among all the forces that shape ring width, water is one of the clearest and most powerful. When moisture becomes limited, the effect can be written into the wood with surprising clarity, leaving behind some of the narrowest and most revealing rings of all. A dry year may pass without much sound. No dramatic mark appears in the sky. No obvious line settles over the landscape announcing that growth will be harder now. And yet a tree can keep a visible trace of that dryness within its trunk. When water becomes limited, the ring formed during that period often becomes narrower, quieter, and more restrained. The year remains there, held in wood. Water matters to a tree in many ways at once. It is needed for photosynthesis, the process by which the tree helps turn light energy into usable chemical energy. It helps maintain internal pressure in cells, which is important for expansion and growth. It also moves through the xylem from roots to leaves, carrying dissolved minerals and helping cool the tree through transpiration. When water is abundant enough, these processes can continue with fewer interruptions. When water is scarce, the tree has to work under tighter limits. One of the first places drought can affect growth is in the production and expansion of new cells. The cambium may remain less active or active for a shorter period. Fewer new xylem cells may be formed. The cells that are formed may not expand as fully as they would in a wetter season. Since the ring is made from the year's xylem production, less growth often means a thinner ring. The trunk becomes visibly more restrained because the tree itself had fewer resources to build with. Photosynthesis can also be reduced during drought. If the tree loses too much water through its leaves, it may partly close tiny openings called stomata to conserve moisture. That helps reduce water loss, but it can also limit the intake of carbon dioxide needed for photosynthesis. As a result, the tree may produce less energy to support growth. This is one reason drought can leave such a clear mark. It affects water movement, cell expansion, cooling, and energy production all at once. A single dry year may leave one narrow ring. A longer drought may leave a whole sequence of them. When several difficult years arrive close together, the trunk can preserve a run of thin growth that stands out clearly from more favorable periods. Those narrow years may reflect repeated water stress, each one adding another quiet sign that moisture remained limited. Looking at such a sequence later, a person can often sense that the tree endured not just one hard season, but a stretch of them. This becomes even more powerful when many trees in the same region are compared. Trees growing under similar climate conditions often show similar drought patterns at roughly the same time. A narrow ring in one tree may line up with narrow rings in others nearby, especially if water availability was the shared limiting factor. That is one reason tree rings are so useful to scientists. The pattern is not always just personal to one tree. It can reflect something larger happening across a landscape. In dry regions, this relationship can be especially clear. Where water is already one of the main limits on growth, changes in rainfall or soil moisture can strongly influence ring width. A wetter year may allow broader growth. A drier year may tighten it. Over time, the rings become a kind of long environmental memory, preserving fluctuations in moisture long after the sky that caused them has disappeared. This is part of how tree rings can help reconstruct past droughts. Even from times before careful written records existed, by studying ring patterns in living trees and comparing them with older preserved wood, scientists can extend moisture histories backward through decades, centuries, and sometimes longer. The trees do not describe drought in words, but they keep evidence of reduced growth when dry conditions return again and again. There is something quietly moving about that. A tree does not escape a drought. It remains rooted where it is, taking what water the soil can provide, enduring the same dry air day after day. If the hardship is strong enough, the wood formed during that time becomes smaller, denser in its restraint, and visibly different from the years around it. The ring does not complain. It simply records what was possible. Water is not the only force that can leave a narrow ring behind. Cold can do something similar in a very different way, especially where the growing season is short and warmth arrives late or fades early. Where warmth arrives late or leaves early, a tree may have only a short window in which to grow. The trunk may look steady and permanent from the outside, but inside it, the building of each ring depends on time as much as on resources. If the season favorable for growth is brief, the tree simply has less opportunity to produce new wood. That is one reason trees in cold regions often leave narrower rings than trees growing where warmth lasts longer. Temperature influences growth in several connected ways. At a basic level, the metabolic processes inside the tree work best within a suitable range. When conditions are too cold, activity slows. Water may still be present in the soil, but if the ground remains frozen or root uptake is limited, the tree cannot use that water as freely. Buds may open later. Leaves may emerge later. The cambium may begin its active work later in the year. All of that means the season of wood production starts later than it would in a warmer place. Even once growth has begun, low temperatures can continue to limit how much wood is formed. The tree may not have enough consistently warm days to maintain strong growth for long. A cool summer can reduce the pace of cell production and cell expansion. If autumn arrives early, the season ends sooner. A ring formed under those conditions may be thinner, not because the tree is unhealthy, but because the period available for growth was simply shorter. This is why trees near the cold edges of their range can be especially informative. In far northern latitudes or at high elevations, warmth is often one of the main things limiting how much growth can happen in a year. That makes the rings more sensitive to changes in temperature. A slightly warmer summer may allow more wood to be produced. A cooler one may leave a narrower band. Over time, those differences can create a long visible pattern, tied closely to the thermal character of each year. Spring timing matters a great deal here. If spring arrives late, the start of growth is delayed. Leaves may take longer to open, and the cambium may remain inactive longer than usual. The tree cannot recover that lost time easily. A shorter beginning often means a smaller result by the end of the year. In the same way, summer warmth matters because it helps sustain the active period when new xylem is being produced. A summer that is mild, brief, or interrupted by cold conditions may leave behind a smaller record in wood than a longer, warmer season would. This is one reason cold climate trees often show such clear yearly patterns. The contrast between a growing season and a non-growing season can be very strong. Winter creates a real pause. Spring restarts the process. That repeated interruption helps make annual rings distinct and readable. In that sense, cold can both limit growth and improve the clarity of the record. High mountain forests offer a good example. Trees growing near the upper edge of forested slopes often live in places where the season is compressed by long winters, cool air, and short summers. They may grow slowly year after year, adding only thin layers of wood. Yet those thin layers can become extremely valuable records because they respond so clearly to changes in seasonal warmth. In northern forests, the same general principle can apply. The farther a tree lives toward conditions that challenge its ability to grow, the more strongly its rings may reflect the years when warmth helped or failed to help. Temperature, then, leaves a different kind of mark than drought, though the result can sometimes look similar in the trunk. Drought narrows growth because water becomes scarce. Cold narrows growth because time and metabolic opportunity become scarce. In both cases, the tree is forced to grow within tighter limits. The ring becomes a visible sign of what the season allowed. There is something deeply quiet about that idea. A tree cannot move south for a warmer year, and it cannot ask spring to arrive sooner. It waits where it is. When warmth comes, it grows. When warmth is delayed or brief, it grows less. The wood keeps the outcome. Not every tree responds to the year in exactly the same way, though, and not every forest produces rings that are equally clear. Species matter, place matters. The anatomy of the wood matters too. Some trunks preserve time more openly than others. Not all trunks speak with the same clarity. By now, tree rings may seem almost universal, as if every tree must preserve time in the same neat and visible way. But trees differ from one another in many important ways. Their wood is built differently. Their growth rhythms are not identical. Their environments place different pressures on them. Because of this, some trees leave behind rings that are easy to see and count, while others leave records that are much harder to read. Part of this comes down to species. Different kinds of trees have different wood anatomy, meaning the cells in their xylem are arranged and shaped in different ways. Some species produce strong contrast between early wood and late wood, making each year stand out clearly. Others form much subtler differences, so the ring boundary can be faint and difficult to follow across the trunk. The yearly pattern may still be there, but it does not always announce itself to the eye in the same bold way. Conifers often provide clear examples because many of them produce relatively readable annual growth patterns, especially in seasonal climates. Their wood structure can make the shift from early wood to late wood easier to detect. Broadleaf trees can also preserve rings very well, but the details vary widely from one species to another. Some hardwoods show strong ring boundaries. Others produce a much less obvious transition. This means that reading tree rings is never only about looking at wood in general. It is also about knowing what kind of tree produced that wood in the first place. Growth habit matters too. A fast-growing tree may lay down broad rings under favorable conditions, creating a trunk that looks open and spacious in cross-section. A slow-growing tree may produce narrow, tightly packed rings, even in years that were fairly good for it. The texture of the record changes with that pace. A slow-growing tree can still preserve valuable information, but its history may look more compressed. A faster-growing tree may appear more dramatic, with broader contrast from one year to the next. Health also shapes the record. A vigorous tree with enough light, water, and space may produce rings that reflect climate conditions quite clearly. A stressed tree growing in poor soil, heavy shade, or competition with nearby trees may produce a more complicated pattern. In that case, the trunk is recording not only regional weather, but the tree's local struggles as well. A narrow ring may reflect drought, but it might also reflect crowding, root damage, insect stress, or some combination of factors. The wood is still telling the truth, but the truth may be more local and less simple. The environment around the tree matters just as much as the tree itself. Two trees of the same species can leave very different records if they grow under different conditions. One might stand on a moist valley floor, another on a dry rocky slope. One may receive full sunlight, another may spend decades shaded by taller neighbors. One may have room for its roots to spread widely, while another is limited by shallow soil or poor drainage. Even though they share the same basic biology, the way their rings appear can differ because their lives are unfolding in different places. This is why scientists often choose trees carefully when studying rings. A tree that is strongly influenced by one clear limiting factor, such as drought or temperature, may provide a cleaner record of that condition than a tree whose growth is affected by many overlapping local stresses. The goal is not merely to find a tree with rings, but to find one whose rings are especially informative for the question being asked. It helps to remember that tree rings are real across many species, but their clarity varies. The idea of one neat ring per year is often a useful starting point, but the visual quality of that record depends on the kind of tree, the kind of wood, and the kind of place. Some trunks preserve time boldly, others do it more quietly. That variation is part of what makes the subject feel more alive. Trees are not identical recording devices placed across the landscape. They are individual organisms, each with its own structure, growth style, and surroundings. The rings they leave behind are shaped by all of that. Time may be present in every trunk, but it is not always equally easy to read. This difference becomes especially interesting in parts of the world where the year itself is less sharply divided. When the seasons are weaker or less predictable, the wood may begin to lose some of the contrast that makes annual rings stand out so clearly. When the year changes less sharply, the wood may do the same. Much of what makes tree rings easy to see in many forests is the strong contrast between one part of the year and another. Cold winters interrupt growth. Warm springs restart it. Dry seasons can slow activity, and wet seasons can renew it. Where these shifts are pronounced, the trunk often preserves them clearly. But in many tropical regions, the year does not divide itself in such dramatic ways, and that can make the rings harder to read. Temperature is one of the main reasons. In temperate and colder climates, the difference between winter and summer can be large enough to slow or nearly stop growth for part of the year. That pause helps separate one annual cycle from the next. In many tropical places, by contrast, temperatures remain relatively warm across the year. There may be variation, but often not the kind that produces a long, strong dormant period. If growth continues more steadily, the wood may show less contrast between one stretch of time and another. This does not mean tropical trees never form rings. Some do. But the pattern is often less obvious, and the reason is tied to the rhythm of the environment. When the conditions that matter most to growth do not rise and fall sharply, the wood may not divide itself into bold annual bands. Instead of a clean visual boundary, there may be a softer and more gradual transition. The record is still there in some form, but it may be fainter, less regular, or harder to follow with confidence. Rainfall can become more important than temperature in these regions. In places where warm conditions stay fairly constant, a tree may respond more strongly to wet and dry periods than to changes in heat. If the dry season is pronounced enough, it can slow growth and help create an annual boundary in the wood. In that case, the rings may still be readable because moisture, rather than cold, is giving the year its rhythm. But if rainfall is spread more evenly across the year, or if the timing of wet and dry periods shifts from year to year, the pattern can become more difficult to interpret. Some tropical species grow in bursts tied to irregular environmental cues rather than one clear yearly cycle. Others may continue growing slowly over long stretches without a strong pause. That can produce wood in which the boundaries between one year and another are faint, incomplete, or uneven around the trunk. A ring may appear clear in one part of the cross-section and much less clear in another. The result is not the absence of growth history, but a more subtle and complicated version of it. This is a good reminder that tree rings are not simply created by the passage of time. They are created by changes in growth, and those changes depend on the rhythm of the place where the tree lives. In a highly seasonal forest, the year may press itself clearly into the wood. In a more constant tropical setting, the same kind of clarity may not appear. The tree is still responding to its world, but the world is asking it to respond in a different pattern. There is something fitting about that. A tree growing in a place with less dramatic annual contrast may keep time more softly. Its trunk may not divide itself into the bold circles people expect from textbook pictures of temperate wood. Instead, the record may be quieter, more blended, and more dependent on careful study. The tree is not failing to remember. It is simply living in a place where the year itself is less sharply outlined. Even in the tropics, though, scientists can sometimes find species and environments where ring formation is reliable enough to study. Strong wet and dry seasons, flooding cycles, or other repeating environmental patterns can still shape growth in ways that leave annual traces behind. The challenge is that the signal is often less universal and less easy to see at a glance. More care is needed, and the local ecology matters greatly. That is part of what makes tree rings so interesting across the world. Their clarity does not depend only on the tree. It depends on climate, on seasonality, on water, on temperature, and on the broader rhythm of the landscape. A trunk is always growing in conversation with its surroundings. When those surroundings change sharply, the wood often shows it sharply. When they change more gently, the record may become gentler too. And yet, whether the rings are bold or faint, simple or subtle, the larger idea remains the same. A tree stores its past in layers. The details of those layers depend on where it stands, what kind of tree it is, and how the year moves around it. Taken together, those layers turn the trunk into something more than wood alone. They make it a long, quiet archive of life in one place. By now, the trunk no longer feels like simple wood. It begins to feel more like slow memory made solid. Not memory in the human sense, of course. A tree does not look back on its life or reflect on the years it has passed through. But it does preserve them. It keeps them physically, one layer held within another, until time itself becomes visible in the body of the tree. That is what makes the idea of a tree as an archive so compelling. An archive is a place where records are kept, protected, and carried forward. In a quiet way, the trunk does something similar. Each year's growth remains in place after it is formed. Nothing has to be rewritten. Nothing has to be translated into symbols. The record is not stored in words or numbers. It is stored in cells. Real tissue laid down under real conditions, still present long after those conditions have passed. This gives tree rings a very different kind of truth than a written account. A page can describe a dry year, a cold year, a favorable year, or a damaging one. A tree ring does not describe any of that. It embodies it. A narrow ring is not a symbol for limited growth. It is limited growth. A fire scar is not a sign standing in for injury. It is injury preserved in wood. The archive is physical all the way through. The tree is not telling us what happened through language. It is showing us what happened through structure. That is why ordinary years matter just as much as dramatic ones. A tree does not only keep the hard years, it keeps the quiet years too. Seasons of fairly steady growth, years with enough water, years without major disturbance, years that passed without anything especially extreme. These are part of the archive as well. They form the background against which stressful periods stand out. Without ordinary years, there would be no pattern to compare. The calm years are part of the record just as surely as the difficult ones. There is something soothing about that idea. A tree does not preserve only crisis. It preserves continuity. It keeps the sequence of life as it was lived, not as it would be remembered by a creature inclined to focus only on the dramatic. Broad rings, narrow rings, gentle shifts in density, the slow outward addition of one year around another. All of it remains, and each layer stays where it was made. That is one of the most remarkable parts of the whole process. When the cambium forms a new ring near the outside of the trunk, the earlier wood is not erased or replaced. It is enclosed. The newest growth forms outside what already exists, and the older layers remain within. Over time, the tree becomes a nested structure of preserved seasons. The present gathers around the past without removing it. This is why a cross-section of wood can feel so strangely complete. It is not just a surface marked with circles. It is a stack of years still physically present in the same body. The tree carries its earlier life inside itself. The center may belong to its youth. The outer rings belong to later years. Between them lies a long sequence of changing conditions, each one turned into tissue and held in place. That does not mean the record is always smooth. Growth often follows a regular seasonal rhythm, but not every year passes gently. A tree can be interrupted. Fire can wound it. Storms can break branches. Insects can strip leaves or damage tissues. Disease can alter its normal pattern of growth. Even the pull of gravity or the force of wind can reshape the way wood is added. The archive, then, is not only a steady sequence. It can also contain disruptions. Those disruptions matter because they remind us that a tree's life is not made only of repeated seasons. It is also made of events. Some years leave behind a simple band of growth. Others leave a mark of disturbance that changes the trunk more abruptly. The archive is therefore both gradual and eventful. It preserves rhythm, but it also preserves interruption. Once that becomes clear, the trunk feels even more alive in retrospect. It is not merely a record of annual change. It is a record of experience, if that word is used in the broadest biological sense. The tree stood in one place through calm periods and stressful ones, through ordinary seasons and damaging events, and the wood kept all of it in some physical form. What appears quiet on the outside may contain a long history of adjustment within. A tree, then, is more than wood. and more than age made countable. It is a layered archive of conditions lived through over time. Each ring remains as a material trace of what was possible in that season, and each new layer gathers gently around the ones that came before. The result is a body that preserves both continuity and change. And when something sudden disturbs that continuity, the trunk can hold on to that too, leaving behind not just a band, but a break in the pattern itself. Some years do not leave behind a simple band. They leave an interruption. By the time a trunk has grown for decades, or even centuries, it may hold more than the calm repetition of one season after another. It may also preserve moments when something broke that rhythm. Fire, storms, insects, disease, and physical injury can all disturb the ordinary pattern of growth. When that happens, the wood may keep not just the passing of time, but the trace of damage. Fire is one of the clearest examples. If a tree survives a fire that scorches part of its trunk, the damage may kill tissue on one side without killing the whole tree. The injured area can become a scar. In later years, new growth may continue forming around the wound. Ring after ring is added, and the edges of the scar can slowly become enclosed by fresh wood. The original injury remains visible inside the trunk, held there long after the flames are gone. In that way, a fire does not simply pass through the life of a tree. It can remain inside the tree's structure as part of its recorded history. This can create a striking image in cross-section. Instead of smooth, even bands circling outward, there may be a wedge-shaped scar or a section where the normal curve of the rings is disrupted. The rings bend around the damaged area, almost as though the tree is growing around an absence. That pattern can help show not only that a fire happened, but roughly when it happened, because the rings laid down after the injury remain in sequence outside it. Fire is not the only thing that can leave such a mark. Insect outbreaks can reduce growth by damaging leaves, boring into tissues, or draining resources from the tree. Disease can have similar effects, weakening the tree and altering the amount of wood it is able to produce. Storms can snap branches, strip bark, or tilt the trunk. Falling debris, grazing animals, or human-made injury can also wound the tree. Each kind of disturbance affects growth in its own way, but many share the same general result. The normal rhythm of ring formation is changed. A broken branch, for example, can alter growth near the place where it was attached. Damage to the bark can interrupt the movement of water or sugars and force the tree to redirect its resources. If part of the trunk is wounded, later rings may grow unevenly around the injured area. Some parts of the trunk may continue forming wood more normally, while others may be slowed or distorted. The result is not always dramatic, but it can still be visible to someone reading the wood carefully. There is something quietly powerful in this. A tree does not erase damage when it survives it. It grows with it. The later rings do not remove the wound. They gather around it. Over time, the injury may become enclosed and less exposed to the outside world, but the trunk still carries it within. The record is therefore not only about steady continuity. It is also about recovery, adaptation, and the long physical presence of what once interrupted growth. This is one reason tree rings can reveal more than climate alone. They can also reveal disturbance. A sequence of rings may show years of ordinary growth, then a sudden injury, then years of altered growth that follow. The trunk becomes a record not just of good years and bad years in the abstract, but of actual events that physically change the life of the tree. Not every scar is easy to interpret. Different injuries can produce different patterns, and sometimes several stresses overlap. A narrow ring might reflect drought, insect damage, or both. A distortion in the wood might come from a wound, a leaning trunk, or uneven local conditions. But when the evidence is clear, the trunk can preserve something deeply specific. Not only that time passed, but that something happened. This makes the tree feel even less like a passive object. It is not simply accumulating layers. It is responding to the world, sometimes under calm conditions and sometimes under strain. A fire, a storm, or a wound can leave a break in the usual rhythm, and the wood can preserve that break for the rest of the tree's life. Years later, the trunk may still show where the damage was and how later growth adjusted around it. The story held in tree rings, then, is not only one of seasons gently repeating themselves, it is also one of interruption and response. A tree can survive an injury and continue building new wood, but the new growth often reflects what the trunk has been through. The record bends, tightens, or wraps around what was damaged. And sometimes, that response is not only about injury on one side of the trunk, but about the whole body of the tree adjusting to weight, tilt, gravity, and motion over time. A tree does not only record the passing of years, it also responds to direction, weight, and pull. A trunk may look upright and still, but trees are always living under physical forces. Gravity is always pulling downward. Wind presses from one side and then another. Snow can weigh on branches. Slopes shift the angle of growth. Nearby openings in the forest can draw a trunk toward the light. When a tree is pushed, tilted, or forced to support itself unevenly, the wood it produces can change in response. This is one reason rings are not always perfectly even circles. In an idealized picture, a trunk might appear to grow outward in smooth, balanced layers. But real trees often live in conditions that are less balanced than that. A tree growing on a hillside may lean slightly downhill or curve upward after starting at an angle. A tree exposed to strong prevailing winds may strengthen one side more than another. A tree whose crown is pulled heavily in one direction may add wood unevenly as it tries to remain stable. The trunk is not only preserving climate, it is also preserving the physical demands placed on the tree's body. This special kind of growth is often called reaction wood. It is wood produced in response to mechanical stress, especially when a tree needs to correct or support a leaning position. The details differ depending on the kind of tree. Conifers usually produce what is called compression wood, often on the lower side of a leaning stem or branch. Broadleaf trees usually produce what is called tension wood, often on the upper side. The names are different because the wood is helping in different ways, but the larger idea is the same. The tree is adjusting its structure in response to force. That adjustment can change the appearance of the rings. One side of the trunk may show thicker growth than the other. The rings may be wider, where extra support was needed, and narrower on the opposite side. Instead of a centered pattern, the rings may look shifted or stretched, with the pith no longer sitting neatly in the middle of the cross-section. This unevenness is not random. It reflects the tree's effort to keep itself standing, balanced, or better aligned over time. There is something deeply revealing in that. A ring is not always just a measure of how favorable the year was. It can also show how much structural work the tree had to do. If the trunk leaned, the wood may record that lean. If the crown was pulled toward light, the rings may reflect that direction. If wind repeatedly stressed one side, the growth pattern may hold onto the evidence. The tree is not simply thickening evenly year after year. It is quietly engineering its own support. Branches can show this too. A heavy branch reaching outward from the trunk is always under gravity. To keep from drooping too far, the tree may produce reaction wood in the branch as well. In that sense, the tree's architecture is always being adjusted from within. Growth is not only about adding size, it is also about maintaining form. Wind is especially important because it can be both constant and unpredictable. In open landscapes or near the edge of forests, repeated wind exposure may encourage the tree to strengthen itself in certain directions. The result may not be dramatic enough for a casual observer to notice from the outside, but inside the wood, the pattern can remain. A tree that spent years being pushed by air currents may keep a subtle record of that pressure long after the weather itself has passed. Slopes create another kind of long-term pull. A seedling may begin growing on ground that is not level, and from the beginning the trunk may have to curve or correct itself upward, while its base remains anchored in angled soil. Later growth can reflect that ongoing correction. The wood becomes part of the tree's effort to negotiate its place in space, not just in time. This broadens the meaning of a tree ring even further. Rings do not only reflect rainfall, temperature, and season length. They can also reflect posture. They can reflect motion resisted, weight supported, and direction corrected. The trunk becomes a record not only of the surrounding climate, but of the physical life of the tree as a body under force. By the time this is understood, counting rings begins to feel less like counting simple circles and more like reading a complicated life. The trunk holds age, seasons, stress, injury, and even the tree's own efforts to remain upright. Each ring is still a layer of time, but it is also part of a structure shaped by real conditions. And once the listener can see all of that in the wood, the act of counting backward through a trunk becomes much more meaningful. Now that you understand how rings are made, counting them begins to feel more meaningful. What first looked like a set of simple lines can now be seen as a sequence of real growing seasons, each one formed near the outside of the trunk and then enclosed by later years. Counting rings is therefore not just a way of measuring age. It is a way of moving backward through the life of a tree, one preserved layer at a time. The usual direction of counting is from the bark inward toward the center. That may feel slightly backward at first, since people often imagine the center as the starting point for growth. But the outermost ring is the newest one, formed most recently by the cambium just beneath the bark. The deeper rings belong to earlier years. The innermost wood near the center was formed when the tree was much younger. A cross-section of a trunk is arranged like a long history, with the newest pages wrapped around the oldest. This means that every step inward is also a step backward in time. The ring nearest the bark may belong to the final full year of growth before the tree was cut or sampled. The next ring in belongs to the year before that, then the year before that, and so on, until the center is reached. If the rings are clear and complete, counting them can provide a useful estimate of how many growing seasons that part of the stem experienced. That last detail matters. Ring counts usually tell the age of the stem at the height where the sample was taken. Not always the exact age of the entire tree from the moment it began as a seed. A tree starts life at ground level and then grows upward over time. The wood higher on the trunk did not appear all at once when the tree first sprouted. It formed later, after the young tree had already spent some years growing upward. Because of that, a ring count taken from a section well above the base may give a slightly younger age than the whole tree's true age from seed. There are other reasons simple counting may not always give a perfect answer. Some rings can be very thin and easy to miss. In certain years, especially under strong stress, growth may be so limited that a ring becomes faint. In other cases, a false ring may appear when conditions shift unusually within a single year, creating a boundary that looks annual even though it is not. This is why counting with the eye alone can be useful, but not always exact. The method works best when the ring pattern is clear and the tree has grown under conditions that produce strong annual boundaries. Still, even as an estimate, the process is remarkable. A person can look at a slice of wood and move backward through decades of life with nothing more than careful attention. 20 rings, 50 rings, 100 rings. Each one is a preserved season. The trunk turns time into something almost touchable. There is also something humbling about the center itself. That innermost wood belongs to the tree's earliest years, when it may have been a sapling facing a very different world. The forest around it may have been denser or more open. Neighboring trees may have come and gone. The climate may have shifted through good periods and difficult ones. Yet that first growth remains buried at the heart of the trunk, still present after everything that followed. When more precision matters, scientists usually do more than count rings casually. They examine patterns carefully, compare samples, and use methods that help separate true annual rings from misleading ones. They may take cores from living trees rather than cutting the whole trunk, allowing the tree to remain standing while still revealing a long sequence of growth. The goal is not merely to get a rough age, but to place each ring correctly in time. That is an important shift. Counting alone tells one kind of story. Careful dating tells another. A simple count may tell how many growing years are visible. More precise methods can help identify exactly which year each ring belongs to. Once that becomes possible, a tree's record can be compared with the records held in other trunks nearby. A single tree can tell a long and beautiful story on its own. But when many trees are read together, their patterns begin to overlap. Wide years and narrow years can line up across a whole landscape, and the life of one trunk begins to join a much larger history. A single trunk tells one life. A forest can tell a shared history. Once tree rings are understood as more than simple age markers, it becomes possible to compare one tree's pattern with another and ask whether the same good years, hard years, and unusual interruptions appear across many trunks at once. Very often, they do. Trees growing in the same region may live as individuals, but they are still responding to many of the same seasons. This is the idea behind cross-dating. Cross-dating is the practice of matching ring patterns across different trees so that each ring can be placed in the correct year. Instead of relying only on counting inward and hoping no rings were missed or mistaken, scientists look for recognizable sequences of wide and narrow growth. One tree might show a pattern like wide, narrow, narrow, wide, very narrow, wide. Another tree from the same area may show the same sequence. When those patterns line up, the dates become much more secure. This works because trees living near one another often experience the same broad environmental conditions. A dry year may reduce growth across an entire hillside. A cool summer may shorten the season for many trees in the same forest. A particularly favorable stretch of years may allow broader growth across a region. Each individual tree still has its own local circumstances, but when the climate signal is strong enough, the overall pattern can repeat from trunk to trunk. That repetition allows one record to support another. There is something almost musical about it. One tree alone may seem to be playing a quiet melody of wide and narrow rings. But when many trees are compared, the same rhythm begins to appear again and again. The forest starts to sound like a chorus rather than a single voice. That shared pattern is what gives cross-dating its strength. It also helps solve some of the problems that simple counting cannot fully avoid. A tree may produce a ring so thin that it is easy to miss. Another year may create a false ring that looks like a boundary, but does not represent a full year. If a person counted carelessly, those mistakes could shift the whole timeline. But when the ring pattern is checked against other trees, those errors become easier to spot. A missing ring in one trunk may be visible in others. A suspicious extra ring may fail to match the regional pattern. Cross-dating makes the timeline more reliable because it depends on agreement across multiple records. This means that trees can be compared almost like overlapping timelines. One living tree may cover the past 200 years. Another may cover 150. If their patterns overlap for a long enough stretch, the shared sequence can help confirm the dating of both. The wider and narrower years become anchor points, and the record settles into place more confidently. That shared dating is one of the most important steps in turning tree rings into a scientific tool, rather than just an interesting visual feature. A counted ring is useful. A dated ring is much more powerful. Once a ring is assigned to a specific year, it can be compared with climate records, historical events, fire histories, and other environmental evidence. The tree's growth no longer floats in approximate time. It becomes tied to the calendar. This does not mean every tree in a forest grows identically. Local shade, soil depth, competition, damage, and species differences still matter. One tree may react more strongly to drought than another. One may be partly sheltered, while another stands exposed. But even with those differences, the broader pattern can often remain visible, especially in places where one major factor such as moisture or temperature strongly shapes growth. Cross-dating is also what allows the story to extend beyond a single living tree. Once a pattern is established in trees standing now, older wood can be matched against it. A dead tree, an old log, or a timber in a building may preserve the same sequence for an earlier period. If the overlap is strong enough, the timelines connect. The living forest can therefore help date wood from the past. An older wood can push the record farther back than any one living tree could reach on its own. That is where the subject begins to widen beautifully. A ring pattern is no longer just the private history of one trunk. It becomes part of a larger network of matching records spread across trees, landscapes, and time itself. And once those overlapping sequences begin to include fallen wood, buried wood, and preserved timber from long ago, the timeline can stretch much farther than the life of any tree still standing. Even after a tree has fallen, its record may still continue speaking. The life of the tree may be over, but the wood it produced does not instantly lose the pattern of its rings. If that wood remains preserved well enough, the sequence of wide and narrow years can still be read, matched, and connected to other timelines. This is one of the reasons tree ring science can reach far beyond the lifespan of any one living tree. The forest's history does not disappear when a trunk dies. Sometimes it waits. A fallen log in a dry landscape may remain intact for a long time. Wood buried in sediment may be protected from rapid decay. Timber used in old buildings can survive for centuries if it stays relatively sheltered. In cold places, preserved wood may last even longer. Waterlogged conditions can also help by slowing the processes that usually break wood down. Not all dead wood survives in a readable state, but when it does, it becomes a valuable extension of the record. The important thing is that the rings remain in sequence. A dead tree no longer adds new growth, of course, but the years it lived through are still present in the wood. If that sequence overlaps with the ring pattern of living trees, the two can be linked. A dead trunk may show a pattern ending before the oldest living tree began. Yet if enough years overlap between them, the older sample can be placed in time. Once that happens, the past is extended. This is how long chronologies are built. A living tree provides one span of years. An older dead tree overlaps with part of that span and continues farther back. Another preserved piece of wood overlaps with the dead tree and reaches earlier still. A timber from an old structure, a buried log, or another preserved fragment may join on again. Each piece is limited, but together they form a much longer chain. The result can stretch across centuries or even millennia. Not because one tree lived that long, but because many separate pieces preserve overlapping parts of the same larger pattern. There is something very gentle about this idea. Time is not held in one heroic specimen alone. It is assembled from many lives and many remnants. A standing tree speaks for its own years. A fallen trunk adds older ones. A beam in an old house carries part of a forest into human history. Piece by piece, the record continues. Old building timber is especially interesting because it shows how human choices and natural records can meet. When people cut trees for houses, temples, bridges, boats, or other structures, they are unknowingly carrying tree ring patterns into the built world. If that wood survives, the rings can later be studied and matched against known chronologies. Sometimes this helps reveal when the tree was cut. Sometimes it helps identify a broader period of construction or repair. The timber becomes both an artifact and a part of a much longer environmental timeline. Buried wood can do something similar in a more natural setting. A tree may fall into sediment, a riverbank, or a dry deposit, and remain there long after the forest that once surrounded it has changed. If enough of the ring structure survives, that wood can still be read. It may preserve a climate signal from a time no living tree can remember directly. The dead wood becomes a bridge between the living present and the deeper past. This is why preservation matters so much. Wood that rots too quickly cannot continue the timeline. But in places where decay is slowed, the fallen tree remains useful long after its life has ended. Dryness, cold, burial, and waterlogging can all help protect the ring sequence. The tree no longer grows, but its record is still intact enough to be joined with others. What emerges from all of this is a sense of continuity that feels larger than any single trunk. Tree ring science is not restricted to the trees now standing in a forest. It can move outward through preserved wood from earlier generations, linking one piece to another until a much longer history appears. The timeline becomes a woven record built from living trees, dead trees, ancient timber, and forgotten fragments kept intact by circumstance. And once those long timelines are in place, they begin to reveal something even wider than the life of forests or the age of wooden structures. They begin to show patterns in climate itself. Good years and difficult years are no longer isolated memories held in separate trunks. Together, they can trace long changes in moisture, temperature, and environmental conditions across stretches of time far older than direct human records. The pattern in wood begins to widen beyond the tree itself and into the history of whole landscapes. Up to this point, the rings have been speaking mostly about one trunk, one life, one rooted organism responding year after year to the conditions around it. But when many trees are dated carefully and their records are compared across long spans of time, the meaning of those rings becomes larger. The trunk is no longer only a record of personal growth. It becomes part of a record of climate. This is one of the most powerful things tree rings can reveal. They can help reconstruct past drought, rainfall, and temperature patterns, sometimes with remarkable detail. A narrow ring may reflect a dry year. A wider one may reflect a year with more favorable moisture. In colder environments, ring width or wood density may reflect the warmth of the growing season. When the same signals appear again and again across many trees in the same region, the wood begins to describe not just what one tree experienced, but what the landscape itself passed through. That is possible because tree growth is often closely tied to environmental limits. In dry places, water may be the main factor shaping how much wood a tree can produce in a year. In cold places, temperature may play that role. When growth is strongly controlled by one major condition, the rings can preserve a clearer climate signal. A tree living where moisture is barely sufficient may respond strongly to wet and dry years. A tree growing near the cold edge of the forest may respond strongly to warmer and cooler summers. These are often the trees that give scientists the clearest climate records. Ring width is one clue, but it is not the only one. In some cases, the density of the wood matters too, especially where temperature influences how late-season wood develops. Other anatomical features can also carry environmental information, but the larger idea remains simple and beautiful. The physical structure of the wood can preserve traces of what the surrounding world was like while that wood was being formed. This allows long chronologies to show far more than isolated good years and bad years. They can reveal patterns that stretch across decades or longer. A sequence of narrow rings across many trees may suggest a prolonged dry period. A run of broader growth may point to more favorable conditions over several years. Over long enough timescales, tree rings can help show periods of relative stability, repeated hardship, or gradual shifts in climate. The pattern becomes less about single seasons and more about the changing character of an entire place through time. There is something quietly extraordinary about that. A hillside of trees, each one rooted in its own patch of soil, can together preserve a regional environmental memory. They do not do this deliberately. They simply grow according to what the years allow. Yet because they respond physically to those conditions, the record accumulates. A forest becomes a network of living witnesses, each preserving part of the same larger pattern. This is why tree rings are considered one of the most detailed natural records of recent environmental history. They do not reach infinitely far into the past the way some geological records do, but within the span they cover, they can be very precise. A ring belongs to a particular year. Sometimes, when carefully studied, it can reveal something meaningful about the conditions of that year. This year-by-year structure makes tree rings especially valuable for understanding climate over the last hundreds or thousands of years, depending on the region and the available wood. They are especially useful because they join detail with continuity. A written weather record might last only a century or two in many places. A tree ring chronology can often push farther back, year by year, without losing that annual rhythm. The result is a bridge between modern measurement and earlier environmental history. The wood helps fill in the time before instruments were watching. And yet, even here, the beauty of the subject remains grounded in something physical and quiet. The tree is not measuring climate in the abstract. It is responding to warmth, cold, water, light, and stress in the direct language of growth. That response becomes wood. The wood becomes a ring. The ring becomes part of a pattern. And that pattern, once matched across many trees, becomes a way of seeing the past climate of a region with surprising clarity. At that point, the meaning of tree rings begins to touch human history in a more direct way as well. Wood does not remain only in forests. People cut it, shape it, carry it into buildings, bridges, ships, and shelters. And when they do, they sometimes carry those ring patterns into the human world, where they can continue preserving time in another form. When people build with wood, they sometimes carry a forest timeline into houses, temples, and ships. A tree may begin its life in open air, taking shape through years of weather, drought, cold, calm, and growth. Then one day, it is cut, shaped into a beam or plank, and brought into human use. Yet even after that change, the rings remain. The tree's history is still present in the timber, and that means wood used by people can preserve time in a very literal way. This is one of the reasons dendrochronology, the dating of wood by tree rings, has been so valuable beyond forest science. If a beam in an old structure still contains enough of its ring sequence, that pattern can be compared with established timelines from living trees and older preserved wood. When the match is strong enough, the beam can often be dated with surprising precision. In some cases, it is possible to determine the exact year, or near exact year, when the tree was cut. That level of precision depends on what survives in the timber. If the outermost rings are still present, especially the final growth laid down just beneath the bark, the date of cutting can sometimes be pinned down very closely. If the outer wood is missing because the timber was trimmed, weathered, or reused, the result may be less exact. Even then, the ring pattern can still place the wood within a meaningful stretch of time. The forest record continues, even after the tree has entered a human structure. There is something quietly intimate about this. A wooden building may look like pure architecture, but inside it are pieces of former living things that once stood through real seasons. The beam overhead may contain a sequence of wet years and dry years, warm seasons and narrow ones, all formed before the building itself existed. Human construction and natural history meet inside the same material. This can reveal much more than a date alone. If different timbers in a structure come from different periods, they may show that the building was repaired, expanded, or rebuilt in stages. If the wood used in one part of a structure was cut decades later than the rest, it may suggest an addition or a replacement. Ring matching can therefore help historians reconstruct construction phases, rather than imagining a building as something finished all at once. It can also help with questions of settlement and trade. In some cases, the ring pattern can suggest not only when the wood was cut, but where it may have grown, especially if regional chronologies are distinctive enough. A timber in a ship, bridge, or large building may turn out to come from a different area than expected. That can hint at trade networks, transport routes, or the movement of building materials across landscapes. The wood, in other words, can preserve part of the story of human decision-making, as well as tree growth. Artifacts made of wood can sometimes be dated in the same broad way. A carved object, a panel, a tool handle, or a piece of old furniture may still contain ring sequences that help place it in time, though the exact outcome depends on how much of the original wood remains and how suitable the sample is. Not every object can be dated precisely, but when the ring pattern is readable, it can provide an unusually direct connection between natural growth and human history. This makes tree rings feel almost like a shared border between two worlds. On one side is the forest, where the tree formed its rings under the influence of climate, soil, and seasonality. On the other side is the human world, where the wood becomes part of shelter, ritual, travel, labor, or daily life. The same rings belong to both stories. They began in one context and continued into another. There is a special kind of calm in that thought. A tree grows quietly for years, perhaps centuries, and then part of it becomes a wall, a roof, a boat, or a floor. The living tree ends, but the layered record remains. The wood continues holding time even while serving a new purpose. Tree rings, then, do more than connect us to environmental history. They also connect natural history to human history in a deeply physical way. A forest's slow record can survive inside the things people build. allowing later generations to ask when a structure rose, when it changed, and sometimes where its wood first grew. The trunk that once stood in one place may therefore continue speaking from somewhere entirely different. And once the human story recedes a little, the scale opens up again toward trees that remain standing for astonishing lengths of time. Some trunks preserve so many years that they begin to feel almost geological, as though wood itself has learned how to hold deep time in living form. Some trees keep watch for so long that their trunks begin to feel almost geological. Most trees do not live for only a few seasons or even a few decades. Many remain standing through generations of weather, slowly adding ring after ring while the world around them changes. But a small number of trees go far beyond even that. They live so long that the wood inside them becomes a record, not just of a lifetime in the ordinary sense, but of centuries, and sometimes millennia. That is one of the most astonishing things about tree rings. They are made by living tissue, one season at a time. Yet in some species, the accumulated record can stretch back farther than many written traditions. A person standing beside such a tree may see bark, roots, and twisted branches. Inside, though, the trunk may hold years from distant centuries, still physically present in the wood. Among the most famous examples are bristlecone pines. These trees are known for extraordinary longevity, especially in harsh, high-elevation environments of the western United States. They often grow slowly, under cold, dry conditions, where survival is difficult and competition is limited. That slow pace, combined with long life, makes them especially valuable for tree ring study. A bristlecone pine may preserve an annual record across an immense span of time, with each narrow ring representing one more year endured in a demanding place. There is something fitting about the fact that some of the oldest trees grow in conditions that seem almost severe. Thin soils, dry air, cold winters, strong wind, and short growing seasons do not create fast, lush growth, but they can favor persistence. A tree growing slowly under such limits may invest more in survival than in rapid expansion. Over many centuries, that patience becomes visible in wood. Very old trees are important, not only because they are ancient, but because they preserve long annual records in a single living body. A tree that lives for thousands of years offers a direct sequence of ring-by-ring information across an enormous stretch of time. Even before preserved dead wood is added to the timeline, one such tree can bridge historical periods that would otherwise feel very distant from one another. The trunk becomes a quiet link between eras. This long life is especially valuable when combined with older wood that has also survived. A living ancient tree may overlap with dead wood from earlier generations of the same species or region. When those ring patterns match, the chronology can be extended farther back still. In that way, deep tree ring records often depend on both extraordinary living trees and the good fortune of preserved older wood nearby. The standing tree holds one part of the timeline. The dead wood reaches into an earlier part. Together, they create something much larger than either could alone. There is a special feeling that comes with this kind of timescale. A young tree can already teach patience. An old tree teaches something even quieter. It suggests that time does not always rush past and vanish. Sometimes it settles into layers and remains there. A ring formed in a year long before modern roads modern machines, or modern borders can still exist inside a living trunk. The tissue itself may no longer be active in the way it once was, but it is still there, carried forward inside the tree's body. That can make a very old tree feel almost unlike an ordinary organism, not because it stops being a tree, but because the scale of its life starts to overlap with the scale of history. A person may live near such a tree for years and never fully absorb what it contains. It may have already been old when entire civilizations were younger. Yet all of that depth is preserved through the same quiet process seen in any other trunk. One growing season, one ring. Another season, another ring. This is where tree rings become especially humbling. The pattern itself does not change. What changes is the length of the record. The same biological process that gives a modest tree a few decades of visible history can give an ancient tree a timeline that feels almost endless when viewed by human standards. Wood, under the right conditions, can hold a very deep kind of time. And yet, even the oldest trees do not give up their record without care. Great age does not make the wood automatically simple to read. Narrow rings can be difficult to separate. Missing or misleading rings can still appear. The deeper the record, the more patience and precision are needed to understand it properly. The record is real, but it is not effortless to read. By now, tree rings may seem almost wonderfully direct. A tree grows, a ring forms, the years accumulate, and the trunk preserves them. In many ways, that picture is true. But natural records are rarely as simple as they first appear. Wood can be honest without being easy. The evidence is there, but it must be read carefully. One reason is that a tree can sometimes produce what is called a false ring. This happens when conditions shift sharply within a single growing season. A spell of drought, for example, may slow growth enough to create a band that resembles the boundary between one year and the next. If wetter conditions return and growth resumes, the tree may continue forming wood in the same calendar year. The result can look like two separate annual rings when only 1 year has passed. To an untrained eye, that can be misleading. Missing rings can create the opposite problem. In a very difficult year, especially where growth is strongly limited by drought or cold, a tree may produce so little wood that the annual ring becomes extremely thin or nearly absent in part of the trunk. The year still happened, but the record of it may be faint enough to miss at first glance. This means that counting rings casually can sometimes produce errors in both directions. 1 year may seem doubled. Another may seem to vanish. Damage can complicate the picture as well. Fire scars, insect outbreaks, broken branches, and wounds can distort local growth. One part of the trunk may preserve the yearly pattern clearly, while another part is altered by injury or unusual stress. Reaction wood can widen one side more than the other. A leaning tree may produce rings that are unevenly shaped. The trunk is still preserving real history, but not always in a perfectly tidy form. Species differences matter too. Some trees produce strong, visible boundaries between early wood and late wood, making annual rings easier to identify. Others form subtler patterns that require more experience to interpret. Local conditions add another layer of complexity, A tree growing in deep shade, poor soil, or intense competition may reflect local stress as strongly as regional climate. Another tree nearby may preserve a clearer climate signal because its circumstances are different. The record is therefore shaped not only by the passage of years, but by the biology of the tree and the place where it lived. This is why tree ring science depends on careful comparison rather than quick guessing. A single suspicious ring is easier to interpret when it is checked against the patterns of other trees from the same region. A missing ring in one tree may still appear in neighboring trees. A false ring may fail to line up with the shared regional sequence. Cross-dating gives the record stability because it does not rely on one sample alone. It asks whether the pattern makes sense across many trunks at once. That patience is part of what makes the science trustworthy. The goal is not to force the wood into a simple story. The goal is to let the structure of the rings, compared carefully across multiple samples, reveal the timeline as accurately as possible. Broad claims are made from many small acts of close attention. A tree ring is meaningful, but its meaning becomes stronger when it is read in context. There is something comforting in that caution. The natural world does not always hand over its history in a neat and immediate form. Sometimes it asks for slowness. Sometimes it asks for comparison, humility, and repeated checking. Tree rings are powerful evidence, but their power comes partly from the care with which they are interpreted. This does not make the subject less beautiful. It makes it more grounded. A tree is not a perfect machine for recording time. It is a living organism responding to changing conditions, and its record carries that living complexity. The rings tell the truth, but the truth may be subtle. It may need to be traced across several trunks, several sites, and long overlapping sequences before it becomes fully clear. By the end of that careful work, what remains is still extraordinary. Wood can preserve age, climate, drought, injury, motion, and time itself in visible form. Yet the more one understands the record, the more natural it feels that reading it should require patience. The listener has been looking, all along, at something both simple and deep. A trunk made of seasons, stored year by year, in layers that remain long after the weather, the hardship, and the passing moment have gone. A cut trunk can look so quiet. A round surface of wood, still and pale, with rings spreading outward from a calm center. It does not move. It does not explain itself. It simply rests there, holding a pattern that was made very slowly, one season at a time. And yet that quiet surface contains far more than it first seems to. What we have really been looking at is time made visible. At the beginning, tree rings may seem like one of those facts everyone learns early and then rarely thinks about again. You count the rings, and that tells you the age. Simple enough. But the longer the trunk is considered, the more that simple fact begins to open. A ring is not just a mark of one more year gone by. It is growth under conditions. It is wood formed in response to light, water, warmth, cold, stillness, strain, and change. It is a year made physical. That is part of what makes tree rings so quietly moving. A tree does not set out to create a story. It does not decide what to preserve. It simply grows, or grows less, according to what the year allows. A favorable season may leave a broader band. A hard season may leave a narrow one. Fire may scar the pattern. Wind may shift it. Leaning, injury, drought, and cold may all leave their influence somewhere in the structure. The tree never narrates any of this. It only continues, and in continuing, it keeps the evidence. There is something deeply peaceful in that kind of record. It is not selective in the way human memory can be. It does not keep only the dramatic years. It keeps the ordinary ones too. Calm years remain beside difficult years. Seasons of steady growth remain beside seasons of stress. The archive is not built from judgment. It is built from continuity. One layer settles into place. Then another forms outside it. Then another. The trunk becomes a long accumulation of lived conditions, each one held within the next. And still, for all its complexity, the image remains simple. Rings widening from a still center. The oldest growth hidden quietly in the middle. The newest growth nearest the bark. The whole life of the trunk arranged in patient order. It is difficult to think of many other things in the natural world that hold time so openly. A tree carries its past inside its own body. The years do not vanish completely. They remain. That may be why a stump or cross-section of wood can feel strangely calming to look at. It offers a version of time that is not rushed. Nothing in the trunk happened all at once. No ring was formed in a hurry. Even the difficult years became only one layer among many. The tree endured them, then continued. Another season came, then another. Over time, the hardships, the calm stretches, and the changing conditions all became part of the same steady form. There is a gentle lesson in that, even without forcing the tree into metaphor. Wood is patient because growth is patient. Structure comes from repetition. Strength comes from what remains. The trunk does not keep the past by clinging to it. It keeps it because each new year forms around what already exists. The earlier years are not erased. They are enclosed, supported, and carried forward. By the time a person understands tree rings this way, a trunk no longer feels like dead material alone. It feels like preserved life, former water pathways, former seasons, former moments of expansion and restraint. The wood is quiet now, but it was built by living tissue responding to a changing world. Every ring is part of that response, and that is perhaps the calmest thought of all. Time does not always disappear as completely as it seems to. Sometimes it gathers somewhere gentle and visible. Sometimes it settles into grain, into density, into pale bands and darker ones, into circles widening almost imperceptibly year after year. Sometimes a tree, simply by standing still and continuing to grow, turns the passing of seasons into something that can still be seen long after the wind, the weather, and the moment itself are gone. So the image returns once more. A cut trunk, a quiet center, rings spreading outward in silence. Not just marks of age, but traces of changing life. Patience made visible. Continuity made solid. Time held in wood.